Welcome to the SolidCAM UK Technology Centre. Inside there we have over 6,000 square feet of office space and shop floor space. Within the centre itself we have 3 CNCs, a 3-axis machine, we have a 5-axis machine, and we have a mill turn, all supplied by Romy CNC. The idea of the Technology Centre is that we can deliver cutting trials, we can do live events, we can showcase our iMachining products, and we can literally show off the software to its best and fullest advantages, which is obviously the biggest benefit to the end user. Inside there we also have our training facility, we have post-processor writing, we have support going on, so we have everything encompassing what SolidCAM is about for the UK. So we're now going to go inside and have a look at what we've got in more detail.
Thank you, Gordon. Hello and welcome to the SolidCAM UK Technology Centre, 23rd of March. Exactly 1 year on from when the UK first went into lockdown. Everyone hoped it would all be over in a couple of months, but here we still are, hopefully looking to come through this in the coming months with the help of vaccines. Let's hope that's the case. Throughout this time, manufacturing in the UK has continued, adapted to the new requirements and generally got on with it. SolidCAM UK have been able to remain fully operational. Support of our customers is our #1 focus. While many of our workforce currently work remotely, we have been and will remain available if required to be on site to keep our customers working, to minimise their downtime. We create and support all post-process in the UK and have added 2 additional engineers in the last year to our team. Their main responsibility is post-processor creation support for complex sliding head machines. This means our customers have 100% local support from the UK. The demand for new machine tools is still high, demonstrated by the fact we now have only 1 machine here in our facility. Both the DCM 620 5-axis machine and the GL mill turn machine have been sold, demonstrating the high demand for these machines. A new DCM 620 will arrive here in May. We are also hopeful of adding a 3rd machine very soon, which will give us the ability for live cutting demonstrations of other areas of SolidCAM, something we're really excited about, so watch this space. The Technology Centre was set up several years ago now with a vision to demonstrate live on the machine the claims we were making were achievable. But these events are more than that. Manufacturing components is not just about a single solution. It's about multiple solutions working together to get the optimum results. Firstly, you need the machine tool. But this can only work well when you add the work holding, the tooling, the NC program, etc. That's why we invite partners to these events, so that attendees can appreciate the complete solution all in one place. Many thanks to our partners today for their efforts in supporting putting this event together. We have the machine, the D1000, supplied by Romy Machine Tools, the work holding supplied by Shunk, all the tooling by Iscar Tools, and toolpath verification by CG Tech, Vericut. We'll be hearing from all of these partners this afternoon. Andy Stott, our UK Business Development Manager, has been catching up with them over the last couple of days. If you have any questions, please type them through the chat section, and we'll do our best to answer them either here live or by email afterwards. When we started these events, we were running them as a mini exhibitions, getting 30 to 35 people in and doing much the same as we are doing today, just face to face. Obviously now we're unable to do this, but in switching to online, we are now able to reach out to many more. Indeed, well over 300 people have registered for this event today. There is no substitute, however, for face-to-face, and when possible, we will return to doing this and hopefully continue to show these events online at the same time. So look out for these events, hopefully later this summer. Today, we are concentrating on iMachining. The machine has been working away for most of the time on the roughing on here as I've been speaking. So enough from me now. I'll pass over to Ben Miller, our applications manager, who can explain more about what we're doing today.
Thanks, Mark. So yeah, as Mark said, we're going to be demonstrating iMachining today, along with some other strategies in SolidCAM as well. We're going to be showing off the partners as well. So I'm going to do a little demonstration of iMachining inside SolidCAM first, and then we'll come back and see the machine cutting live with those tools.
So just going to have a quick look at SolidCAM as a package, what we can offer, and also the iMachining technology that we're using here today with our roughing. So SolidCAM works with inside SolidWorks. It's got the same look and feel in a seamless single window integration, full associativity for toolpaths, and also working with the assembly mode to define fixtures, tooling and vices, etc. SolidCAM's been gold partners with SolidWorks for over 17 years now. So SolidCAM works like building blocks, so we have modules inside SolidCAM. We can start very small, just with 2.5D machining for instance, and then you can add modules as you go along for more advanced things like 3D milling, iMachining, 5-axis simultaneous, sliding head, advanced mill turn, and so on. So SolidCAM's iMachining, we've got 2D and 3D iMachining. So this is our high speed roughing strategy. So this is a patented technology by SolidCAM. Cycle time savings of 70% and more, increased tool life, brilliant on hard metal machining as well, and outstanding tool performance. Yeah, we've also got a unique technology wizard providing optimal feeds and speeds, taking into account the toolpath, the stock, the tool, and the material as well as the machine specifications. So iMachining is a two-stage process. So the first part of iMachining is its intelligent toolpath, so it's efficient tangential toolpath, so we're ensuring constant load on the tool. And then the second stage of iMachining is its technology wizard, so calculating the cutting conditions for a given machining operation. So the iMachining technology already knows the machine we're using, so all its parameters. We give it the tool information, we give it the stock and material information, and iMachining will calculate its own speeds, feeds, step overs, depths of cut, its cutting angles, as you can see here. So we vary the cutting angle as we are cutting with iMachining to keep that constant load on the tool. So when we have on the minimum cutting angle, we are going at a higher feed rate than when we're on our maximum cutting angle that iMachining is calculating. So you can see here when we've got a 20-degree cut angle, the feed rate is at 3,792, and when we're up to then 50 degrees cutting angle, the feed rate is at 1,675. So we are varying the feed rate as we are cutting. Also in the iMachining, we've got two patented features in there. So we've got morphing spirals, and we also have the intelligent separation as well, so what we call channels. So you can see here, rather than the tool working and cutting the entire section of that component and bumping into the wall, what we do is we cut a channel against the wall first, and then we cut two more channels, creating what we call islands. So you can see there are 3 islands in that section. The islands are then cut using the morphing toolpath, so these final spirals you can see here. These are then cut using the iMachining technology, so we're minimizing any thin walls. Now this is the technology wizard inside iMachining. So we give it the parameters, so we tell it what material we're cutting, the geometry, so that's our stock, our tool that we're using, so we give it the number of flutes and the helix angle and such, and the machine as well, so the machine's maximum spindle speed, maximum feed rates, etc. iMachining will then calculate the spindle speed, the depth, the feed rate and the step over for us, and then we can generate the G-code. So with iMachining, it takes the headache out of being able to get those components correct and gives us those. So what we're looking for is a low axial contact point as well, so, or a round number should I say. So an ACP of 1, you can see the contact there between the helix angle. ACP of 1 means we're going to get no vibration, and in the software that will be shown as green. An ACP of 4.5 for instance would tell us that that is going to vibrate. iMachining will trap that out and it will give us a good round ACP, so it will adjust the depth of cut to give us a nice round ACP, giving us that nice green cutting condition that we need. So looking at the component in SolidCAM, I just wanted to show you how we're holding this component straight into the 0 point vise from shrunk. If we have a look at the exploded view of the assembly here, just have a look from underneath, you can see we've got the SPA pin and we've also got the anti-rotation pin. So these screw into the component directly, and then we pull this down pneumatically into the pot. Shunk will be talking about this a little bit more during the day. So looking at how we've programmed this component today and looking at the iMachining that we've been talking about, you can see here I've got a 12mm tool from ISCAR, and if we have a look at the iMachining settings, so we're using 3D iMachining, we've selected the target to machine. The tool is the 12mm tool. I'm going to take out the bulk of the material, 37° helix on there, with 7 flutes and also the chip splitters on there. So this is a 3xD tool and we're going to be using it to the full depth. You can see here 1 step 29.8, 1 step down. So we've got a nice green ACP 4.17. We're up at the maximum machining level, giving us a 1.2mm step over, so 10% of the tool, with a 161 surface speed, chip thickness of 0.053. And if we have a look at that tool path on the component, you can see we've got that nice smooth tool path that we were talking about. So we've got the morphing spirals on there, and we've also then got the iMachining with the 8mm tool, so taking out any areas where the 12mm tool couldn't get to, so for instance this channel down here and the channels between. We've also got a cusp control on here, so we're doing some rest roughing at the same time to take out the dishes and leave a scallop on there for finishing. And then we go right down to a 6mm end mill as well, using iMachining again to rough out the slots here. Again, the tool is 3xD, so we've got 18mm flutes and we're going down 17.86 depth of cut with a 10% step over again, 173 on the surface speed with a 0.044 chip thickness. So let's have a look at this running on the machine, and we'll be able to see iMachining cutting using those small tools again as well.
So that was the iMachining demonstration. So while we've been, while Mark was talking and while we've been doing that presentation, the 12mm roughing tool's actually finished its iMachining. So that was running at a 30mm depth of cut, 161 meters a minute with a chip thickness of 0.05. So giving a maximum step over of 1.2 millimeters. The 8mm running now. So you can see there we're cutting live. This is the 8mm tool again. 30mm depth of cut. This is a 5 flute end mill. We'll hear more about the end mills and the tooling used from ISCAR shortly. So coming up today as well, we're going to be talking about SolidCAM 2021 as part of the agenda. So we'll be launching the new version soon. So we're going to show some of the enhancements and features in there. We're going to be talking a little bit more as well about some of the more advanced features in SolidCAM, like advanced mill turn, sliding heads, 5-axis, things like that. We've got lots of interviews coming up with the partners as well, talking about how they've contributed to the event today, what they've brung to us today as well. So we'll be hearing from those people shortly as well. You can see the 8mm M-mill here, getting through that channel in the centre of the component. We're also going to be talking about mirror machining later as well. So you'll have seen in the presentation the components actually mirrored on the top of this material. We're cutting the N24T as well today. That's the material we're cutting. So yeah, we're going to be talking about mirror machining, how we've mirrored the toolpath. So we only actually program one component, mirrored over to the other side. Any highlights coming up for you today, Mark, that you think
Well,
of?
obviously we're going through the sliding head support later on, which will be very interesting to go through. The 2021, there's some really nice enhancements, especially to the tool library and to simulation. There's various things in there. There's a bit of everything for everybody in that, so that will be very useful to actually go through. We're only going to give you a quick, brief overview today. For UK customers, there's training courses which were advertised on there, sort of days overview, so that our customers can get into 2021. They're all being scheduled at the moment, or have been scheduled, so they'll be available to our UK customers as well.
Yeah, the training courses will be. I think they've already been sent out, the dates, but we'll resend those out as well. Anybody interested in those, just contact us and we'll get you booked on. We're going to hear from Romy first. So Andy caught up with Romy a few days ago. They're going to tell you a little bit about how our partnership works and what they've brought to the event today.
So we're speaking this afternoon with John Brindleton from Romy UK. Good afternoon, John.
Good afternoon.
Nice to have you with us on our SolidCAM Live event. For those who aren't familiar with Romy UK, can you give us a bit more information about Romy and who you are?
Yeah, sure. So Romy Machine Tools are the largest machine tool manufacturer in the southern hemisphere of the world. They've been designing and manufacturing machine tools for over 90 years now. They've obviously got quite a good history and reputation. They design and build a lot of their machines in-house, or all of their machines in-house, but more importantly, all of the castings for their machine range are produced at Romy's own foundry. There's very few machine tool companies out there who actually do this. So to put some figures on it, 50,000 tons of casting a year are produced at Romy's foundry. This is purely for our machine tool and not including all the competitors' castings that we produce.
Okay.
They also employ over 6,000 people worldwide, with the headquarters based in Brazil, and they have 13 manufacturing facilities, including 2 in Germany. Now, closer to home, Romy UK, we were established in 1975 as Sandretto UK, and they've sold over 3,000 injection moulding machines, because as you might be familiar, in Romy have 2 main departments, which is machine tools and injection moulding.
Okay.
Romy acquired Sandretto in 2014, and then they added the CNC machine tool range to the portfolio, and it's grown from there. So now we've got a range of machine tools from, teach lathes up to extra heavy duty flatbed lathes, oil and gas industry, as well as vertical machining centres, slant bed lathes, all the way up to 5-axis machining centres.
Also got a comprehensive range then.
Yes, definitely.
Oh, that's great. Well, for today's demonstration at the Solid Live, we're using one of the D1000 machines of yours. Now, I'm aware it's a V4 variation, and I believe you've already moved on to the V5. Could you give us a bit of information on what the changes are?
Yeah, I mean, there's always a transition with new machines coming out and obviously older stock. And going forward, the V5 is the only machine that will be able to be purchased. So there's a handful of the V4 machines still available in the UK. So the Generation V5 D series, it's a completely new, redesigned, restructured design, and it's built from the ground up. So I actually have a 115-page presentation about every difference between the V4 and the V5 range, but we wouldn't be able to squeeze this into this interview. I don't think anyone would want to hear it, to be honest.
Probably not, John, no.
No, but as a brief overview, the capacity for the machine with regards to the XYZ travels, things like that, they're unchanged from the previous version. The new generation now comes with a direct drive 10,000 RPM spindle as standard, and you have an option for a 15k spindle. This is completely different to the previous generation. Then you also have increased spindle power and torque. You've got an improved tool change and chip-to-chip time. 40 meters a minute rapid traverse compared to 30 meters a minute. Larger diameter ball screws, things like that. Even down to steeper angles on the telescopic covers for the ball screws, which helps with chip flow and better swath management. The overall weight of the machines has gone up significantly as well. To give you an idea, on the D600, it is 86% heavier than the previous generation. The D800 is 76%, the D1000 is 22%, and the D1250 is 26%. And as we know, a more heavy machine is a more rigid and a better performing machine. They now have roller linear rails as well, which is different from ball linear rails. You've got better contact surface area on these, which means you get an improved surface finish, an improved tool life. And yeah, finally, there's one of the more significant differences, in my opinion, is the control system. On the new Generation 5 machines, you've got this big FANUC HMI control, which comes complete with a 15-inch touchscreen display. Now, there's numerous advantages to this new control system. It's one of the most latest ones that FANUC have released. It's a hell of a lot more user-friendly than previous ones. It's easier to navigate through different pages. You can create shortcuts, and it's just a bit more this century, shall we say.
Yeah, well, obviously things are moving forward at Robbie. Once again, thank you for your time, John. I hope you enjoyed the SolidCAM Live event today, and we'll see you soon.
Thank you very much.
Thanks, John. Bye-bye.
Yeah, thanks for that, John. It's good to obviously do these events alongside Romy, and hopefully that partnership continues. So the 8mm M-mill's still running here. It's just doing a bit of rest roughing, just taking out the 3D shape. The 6mm cutter's coming up soon. We had a few questions in regarding iMachining while this has been running as well, so I'll let you answer this one, Mark. What are the differences between iMachining and adaptive clearance operations in other systems?
Typically, there's two real main differences. One is in the programming side of things, where SolidCAM has the iMachining wizard on there, which will calculate and to recommend all the cut data, the step overs, the engagement angles, automatically for you. You put in the material, the tool you're using, your machine details, and SolidCAM will do the rest on there. So that's one major difference on there. Typically on there you'll be finding tooling suppliers will give you recommended cut data for this type of machining now around a set parameter, so maybe typically 2D depth of cut and 10% step over into material. But what if your profile's not that depth of cut? Do you increase your step over to compensate? It's always a question which you'd have to normally just take a gamble at. But with iMachining, with the wizard on there, it will give you all that information. The second major difference is actually in the toolpath itself. Rather than have a constant step over all the time, we will have a constant chip thickness. So when you're changing shapes, say for this particular component, we're changing from a round billet to go into a weird and wonderful shape in the middle. Rather than have a constant offset with a constant step over on there, we'll actually morph between the two shapes. which means our step over is actually going to change. And to compensate chip thickness then, the toolpath is analysed at every point, and the width of cut determines then the feed rate to change the, or to maintain the chip thickness. So rather than just a constant step over on this, it's a really intelligent toolpath.
Yeah, and it's again, having that wizard, all that knowledge built into SolidCAM comes from obviously years of experience, and obviously all automatic. There are some overrides that you can use as well, so you can take control of it at the same time. The 6mm cutter's working away now, so this is 18mm depth of cut on this 6mm tool. It's a four fluted tool, so we're at 173 meters on the speed, and with a constant chip thickness of 0.045. So we've got a max step over of 0.6, but as Mark said, we're adjusting the step over as the toolpath morphs between those tool shapes. So, have we got any more questions coming in?
Yep, there's a question coming, I don't mind. Do you want me to answer this one or you?
Yeah, I'll let you answer this one again, Mark.
Okay, basically, should I use iMachining for all metal removal, for all pockets? I'd love to say yes, but there are going to be some occasions when other strategies are going to be better for it. In most cases on there, iMachining will machine the pocket in the most efficient way. But as you saw in the presentation earlier, it will calculate the step over and the engagement angle based on the depth of cut, the material and everything else on there. And if you don't have enough engagement on the tool, if the pocket's too shallow, it will recommend either changing the tool or changing the strategy on there, because if we haven't got enough engagement, we're predicting vibration in the cut, and that can be detrimental obviously to the machining itself. So if the pocket's really shallow and is covering quite a big area, then probably not. But in pretty much every other case on there, yes, I'd use iMachining, certainly above any standard pocketing operation.
Yeah, definitely so. So we're going to move over to ISCAR now. So ISCAR supplied all the tooling and the back ends for this project or this event. So we're going to pass over to Ian, where he caught up with. We're going to pass over to Andy, where he caught up with Ian from ISCAR a few days ago.
This afternoon we're speaking with Ian Cooper from ISCAR. Good afternoon, Ian.
Afternoon, Andy.
Thank you for participating in today's SolidCAM live event. Could you like to tell us a little bit about the tooling we're using?
Yeah, well, the tool we're using for the iMachining strategy, Andy, is a diameter 12mm tool with a 3x D maximum flute length, and also an 8 diameter tool with a 4x D maximum length. And one of the things that we've got on these particular tools is they both have chip splitter geometries, and with the longer reach tools, this is a good benefit to the tools, as it breaks the swarf up into much more manageable pieces, and also reduces the amount of deflection on the tool, because it's, as I say, a much smaller piece of swarf, less cutting pressure on the tool itself. So this enables us to use the longer reach tools on the smaller diameters very effectively within the iMachining strategy itself.
Well, thanks a lot for bringing along and showing us these tools. Is there anything else new within the ISCAR range you'd like to discuss?
Also, what we're using on the demonstration is we have a small concave section on the demo, and what we've implemented on this part is the lens style barrel mill tools, which have been recently added to the ISCAR range, and we've used these within the multi-master range itself. So this is a very small piece of carbide directly screwed into a shank, and this enables us to minimise cost, and also we have the benefit of the lens diameter, lens geometry, which means we can use bigger step overs, and again faster metal removal rates, up to 4 times faster than what would be a standard bull nose for these types of operations.
Obviously, faster metal removal falls in line with the SolidCAM iMachine technology. Is this something you've thought about using in the future?
Yeah, this is obviously something we do quite a lot of now, as far as we're concerned. metal removal rate is the best way to offer cost savings to our customers, because if we can move metal as quickly as possible, then we can go from start to finish on the part and give massive cost downs.
Well, that's great. Well, once again, thank you for helping out with the SolidCAM Live event today, and we'll look forward to seeing you in the future, Ian.
Thanks very much, Andy. Cheers.
Thanks again. Bye-bye.
Yeah, thanks, Ian. Great set of tools. So we had a good day proving this out last week, me and Ian. So yeah, it was good to catch up with you again. The machining now, we're on the finishing. So this is the 8mm finisher now. So it's just finishing the floors. And when we finish the floors as well, we're standing away from the wall by 0.1, so that we're not cutting on the bottom of the tool and the side of the tool, and then we're going and finishing the walls now separately. So we've done 2 separate operations for that as well. So the 8mm finisher is a 7-fluted mill, running at 210 meters on the speed, running at 2 meters a minute on the feed rate. Gives a nice lovely finish around the outside of there as well. So that's this tool. The 6mm finisher's coming up shortly as well, so you'll see that coming. That's going to finish those pockets on there as well. So in terms of questions as well, is it possible to use an STL file for a shaped tool? So I'll answer that one. I'll give you a break. I'll give you a break, Mark. So yes, it is possible in 2021. We can use an STL file for a shaped tool, a holder. We can also do that in turning as well, so we can use a solid model for the insert. STL files, step files, we can use all of those as well. Is SolidCAM only available as an add-in to SolidWorks?
You want me to take that one?
I'll let you take that one, Mark.
No, it's not. It's a short answer on there. Obviously, if you've got SolidWorks, it's a natural add-in to it. It's one of our most important USPs on there, is the fact we're working with SolidWorks. But we also work with Inventor, and it gives us exactly the same USP in that environment. So we also have InventorCAM, exactly the same product works in that environment. So obviously we work with the 2 sort of mainstream solid modelling softwares on there. The iMachining, which you're seeing most of today, is also available as an add-in for NX as well. So for our NX users on there, they get another option on there. They can add this into existing NX systems on there to give them the best of this strategy as well.
Good. So yeah, the lots of different options. If you're interested in add-ins for different CAD systems, obviously, as Mark mentioned, just let us know. We can show you those. We can do demonstrations. Again, we could come do on-site demonstrations, as we're already still doing as well. So the 8mm finisher's just finishing off there, and then the 6mm tool's going to come in. Now for holding this component today, we're using Shunk's work holding as we have before. But this time we're using a 0-point clamping system that we normally have here. But this time we've put the SPA pin directly into the material to pull it down. So Marcel from Shunk's going to give us a little bit more details on that and how that works.
So today we're talking from Marcel from Shunk. Good afternoon, Marcel.
Good afternoon, Andy. How are you?
I'm very well, thank you. Marcel, we're using the Shunk technology today for our SolidCAM Live event. Could you give us a little bit more information about what we're doing?
Sure. So yeah, today we have a 0-point solution on the work holding side of this application. So we used 0-point with you guys before, some of your previous events. You've been using this system. But today you guys took an interesting approach to the cutting strategy. So normally, if you're familiar with 0 points, so if you're not familiar with 0 points, essentially It's a pneumatic system that you feed air into it, it unlocks, you drop your parts on top of it. Normally, you would have a vise, so you would preset your vise. The vise would have the clamping pin underneath it. You feed air into the system, that unclamps, you drop the vise in, pull air, and you're done. So essentially it's a zero-time setup. And incredibly not very popular in UK. We see that used extensively in Germany. We use a lot in our factory, of course, but we don't see that as so often in UK. So anyway, so it's a zero-time setup, which normally involves the actual 0 point plus a other solution on the work order. Today, the demonstrations you guys are doing uses quite a sophisticated and quite complex profile. And to achieve that, you guys took a even less common approach, which you put the locking pin directly into the workpiece. So that means that you have all surfaces available to work, which on a 3-axis machine gives a great extra capacity to it. But if you're using the same approach on a 5-axis machine, that gives you a full-on access to the workpiece. It's a very, very interesting strategy.
You said earlier that it's not a common approach in the UK. Is there any reason behind that?
Well, it's hard to say, but normally what we see is people don't appreciate it. It's lack of experience, I guess, because it's not even the cost. I think it's so alien to us. I mean, I come from the machine tool industry. I wasn't that familiar with the system myself before joining Schunk. And when we explain it, it sounds too abstract. Like it's so simple. The application is so simple. The actual execution is so simple that people don't, I think, quite grasp how good it can be for them. So unless they actually see it in action and possibly see it in front of them, I don't think they appreciate how revolutionary it can be for their productivity. So all they see is a price tag. So, the system starts from a few £100 and can go up in price as you increase the complexity. But what we can say, every time we put the system, the return of investment, it's anywhere between 3 to 4 months to maximum 1 year, year and a half, depending on the complexity of the system. So the return of investment is there. I think it's the difference in approach, I guess. People don't really appreciate. So because what normally happens, people will think, all right, so I only have the one job. Well, I don't do changes of setups that often anyway. So my gain in setup is not going to be massive. But even if you have the same job where you're changing parts a few times over the day, so you're doing that one job that we're doing here today, that has a cycle time of, let's say, a couple of hours, and you're going to be running there 4 times in a shift. So even just that will bring you an immense gain in productivity, because it eliminates all the time that you have on the changeover. It literally takes seconds to go from finished part to a new blank. So I think it's just giving the chance of actually seeing it, and then that would eventually change the culture. But yeah.
Well, I'm glad we could obviously highlight this opportunity for Schunk. Thank you for your time, Marcel. Always a pleasure, and we look forward to working with you in the future.
Thank you very much. Thanks for having us again.
No problem. Goodbye.
This the lens?
Thanks, Marcel. Yeah, this is the lens marker.
I'm just catching up to find out where we are.
So this is the lens tool running at the moment. You can see there on the cutting. So the lens tool, it's a 10 diameter shank, so a 10 diameter lens tool with a 20mm radius on the bottom of it. And it's got a 1mm corner radius on as well. So this is doing a 0.7mm step over to achieve the surface finish, a real good surface finish. Now when I mirrored this toolpath, I then edited the mirrored version, and we've done a 1.4mm step over on the other side of the component. So we can see the difference in the finish. And actually the 1.4mm step over was quite a good finish, depending on what you're after. You could just about feel the marks in it, but the 0.7mm step over, real good, nice shiny finish on there as well. We've got a question here, Mark, from Grant in Australia. He says he wants to know when you can get together for some beers again.
As soon as we can, mate, as soon as we can. Bangkok's on for me.
How important is the quality of the tooling for iMachining?
Sorry, I'm still thinking about beer in Bangkok.
As usual, Mark's still thinking of beer. So yeah, how important is the quality of the tooling for iMachining?
Decent quality tool is going to make a difference. It's not just the tool, it's the back end holding of the tool. There's a lot of components come together, but obviously the better the tool, the better the same software as being the best. So we're saying exactly the same thing from the software point of view. Yes, with iMachining you can get away sometimes with cheaper tools, but you'll half notice the difference when you go for the proper ones. Yeah, definitely. I've seen that myself firsthand. As soon as you put a good tool in there and you're using iMachining, you can definitely tell the difference. The cutting's so much smoother and sweeter on there. So the lens tool's working away there now, as you can see. So just doing a nice little step over, spiral step over in that dished area on there. So we're going to talk a little bit about SolidCAM 2021 now, and a little bit about what's new in 2021. So I've got a little presentation with some highlights of some of the big things that are new in 2021. But first, we've got a little message from our from the CEO of SolidCAM, Emil. So I'm just going to pass over to him, and then I'm going to do my presentation.
Hello to all SolidCAM UK staff, current customers and potential customers watching this very important event. SolidCAM UK is one of our most important affiliates worldwide. We started working with SolidCAM UK nearly 20 years ago. SolidCAM UK was founded as a perfect cooperation endeavor of two powerful and talented people, Gordon Drysdale, the sales and management wizard, and Mark Stokes, the technical and post wizard. SolidCAM UK were always the early adopters of our newest development and technologies, starting from SolidCAM integration in SolidWorks and then in Inventor to our revolutionary iMachining technology, our simultaneous 5-axis, our advanced mill turn solution, and now to our Swiss type solution. SolidCAM UK has 15 staff today with excellent technical support and post team. Hello to all SolidCAM UK staff, current customers and potential customers watching this very important event. SolidCAM UK is one of our most important affiliates worldwide. We started working with SolidCAM UK nearly 20 years ago. SolidCAM UK was founded as a perfect cooperation endeavor of two powerful and talented people, Gordon Drysdale, the sales and management wizard, and Mark Stokes, the technical and post wizard. SolidCAM UK were always the early adopters of our newest development and technologies, starting from SolidCAM integration in SolidWorks and then in Inventor to our revolutionary iMachining technology, our simultaneous 5-axis, our advanced mill turn solution, and now to our Swiss type solution. SolidCAM UK has 15 staff today with excellent technical support and post team. They just recently hired 2 advanced mill turn and Swiss type post staff to support their major push in the advanced mill turn and Swiss type market. They have also established a remarkable SolidCAM UK Technology Center where today's online event is being held. We are releasing shortly to our customers on subscription our new powerful version SolidCAM 2021. It has amazing new functionalities in all fields, including a powerful new tool table, a new amazing simulator, and further functional improvements in 2.5D milling, 3D milling, iMachining 2D and 3D, simultaneous 5-axis, advanced mill turn, and Swiss type. Any customer not on subscription would better go back on subscription fast to get this powerful version. Also, I want to invite everybody to attend our online SolidCAM Virtual Summit 2021 to be held on April 6 and 7. You can register through the homepage of our website. Do not miss it. You will be glad that you attended. To sum up, following the very challenging year 2020, I wish you all a very successful year 2021. I hope you enjoy well today's event.
As mentioned, we're going to have a look at some of the new features and functionality of SolidCAM 2021. So the component today, I'll start with this project that we've already got open. Now this is not a new feature of 2021, I just wanted to show you the power of SolidCAM. And you may have noticed in the previous presentation that this component is a mirrored component. You can see the logos on the other side are mirrored as well. So the entire solid has been mirrored in CAD. So I'm going to select the operations. You can see all the finishing operations there on that first component. I'm going to highlight them, right click and mirror in the correct plane. I'm going to add them as new operations in their current position using the existing coordinate system. Click OK to that, and the toolpaths are quickly and easily mirrored to the other side around that plane. You can see there, nice and easy. Climb milling is respected, so the directions are reversed so that we're still climb milling. Each operation has been inserted after the original operation, so we're maintaining, keeping the same tool in the spindle all the time as well. Now, an announcement for 2021, one of the new features is our new SolidCAM simulator. So you can see here there's lots of options on the menu, solid verification. We can show the holders, the tools, we can hide things. We've got themes as well, so we can view it in a Solid Verify theme, 3D theme. I'll go back to the default theme here. It's a nice fresh looking theme. You can create your own themes as well. So if I click play, we can see here that we've got the component running. Currently got the verify on there as well whilst it's running in the simulation. So that's something new that we can do. We can verify how much stock is left on the component. We can use the slider as well to adjust the colours for the different amounts of stock left on there, and you can leave that view on as well while simulation is running. You can see here it's a nice fast and powerful simulation. I can also change the option to be stationary tool, so it's the component that moves around the tool instead. So if you'd rather see the tool static, you can do. We've switched it back here to the component being stationary. We've got the speed of the simulation there that can be altered as well. And we've also got some different options here. So I'm going to turn off the stock itself and turn on the target. So I can play the simulation against just the target. So instead of seeing the stock removal, we can see the tool moving. We've also got this slider bar here split up into the operations, so we can go back and forth through the slide, through the operations using that slider bar. You can see that there. You can see each colour is a different tool and each segment is a different operation. So again, I'm gonna reset this simulation and switch the stock back on and turn the target back off. So again, you can see how much stock is left on the component, or how much, if there are any gouges. So the gouges, if you've got the slider bar at the top, will be highlighted in red. And you can see the slider bar at the bottom as well. I said there it's split up into operations. It tells you which operation each segment is and how long each segment takes as well, so each operation. So you can see it says time and then the actual time of that operation of, and then the end time is the full time of the tool as well. So it's giving you total time of the tool and then the individual time of the operation. Moving on, we've got a new tool table for 2021. So this is our major announcement in 2021, or one of the major announcements in 2021. This brand new tool library available in the new version. So this tool library can be opened outside of SolidCAM, so it can be opened as a standalone product. We can manage the tools in the tool library and all the assembly components of this tool library. There are three sections to the new tool library. We've got tool components, tool assemblies, and machine tool setups. So the tool components are all things like your tools, your holders, any shanks and adapters, anything like that are built into the tool components. The tool assemblies are then tools made up of those components, so we would create the assemblies ready for use on the machine. Machine tool setups are then that we can set up the machine, so we can load the machine with tools before we even start a CAM project. So for instance, on a sliding head machine, we might want to lay out all the tools that we have in a standard position. The same for maybe on a lathe with a turret. We could load the tools up into positions. We create cutters, shanks, adapters and holders in a structured folder system that we've got here, you can see in the components library. The tool assemblies library then allows us to drag and drop these elements together to create this tree. So you can see there on the right hand side the tool assembly is made up of a HSK63 holder, then the fly holder for holding the face mill, then the face mill itself, and then we define the cutting point on the end. Again, we can easily add components to the tool library, so you can create standard sets of components so that we can just quickly and easily assemble these tools when we need to use them. We create the tool assemblies by using the drag and drop method, as I mentioned. So you can see here that we're adding a square shank to our tip. So we created the tip, we're now adding the shank to it. We can create tool assemblies from STL models as well, so we can use any models that we download. You can see here we're using an ISCAR model to create that tool holder. We can also create quite complex tool assemblies as well, such as this one here, where we can mount 6 different tools into different positions. So we would create this holder fits in one station on the machine, but this station or this holder then has 6 different joints on it, so we can mount the tools in different joints, different cutting points using different offsets, and this is then all controlled in the output from the post processor. Again, we can have angle head adapters, so again we've got different mounting points. We've got 2 joints on this one here, and again we can manage all this from the post in terms of output once we've created the tool quite easily in our new tool library. We've got quick access data as well, so we can quickly identify the tool numbers. Here we can see the mounting on station, so we can change the mounting station quite quickly and easily using this drop down list in the tool section. We can also add different cutting condition data, so we can add different cutting conditions for different materials to our tool itself, so that when we use it in SolidCAM we can use the correct data for that material selected. And we've also got the option for cutting points. We can change the cutting point, and we can also add cutting points, so we can have multiple cutting points as in this image here. So we've got one tool, it's a slot mill, and we've got 2 different cutting points on there, so one at the bottom of the tip and one at the top of the tip, so that we can use that with 2 different H offsets. We've also got nose point management for the turning tools, so we can choose where the tool is set from, and we've also got the ability to load in our previous tool libraries as well from our previous version. So the .tab files that we've been creating in SolidCAM in previous versions, they can also be imported into our new tool library for a quick transition. We've also got quick toolkit filtering as well, so we can filter out for specific tools when we're trying to find them if we've got a vast array of tools or holders. We've also got visualization on the machine, so you can see the tool mounted on the machine, make sure it's mounted correctly and in the right position. And we've also got visualization of the cutting point, the mounting positions, the station mounting positions, any joints and things as well. And we've also got the being able to have the tool on the tip of your mouse in the graphics area, so that you can see any visual checks, see if the tool fits in that area, make sure you selected the correct size tool, etc. And then lastly, we have an advanced view as well. For more advanced tool management, we can see what stations each tool is in and all the mountings, the holders, the driven points, etc.
So that was some of the major announcements there in SolidCAM 2021. Apologies for the sound issue there on Emil's video. I think I sorted that and restarted the video. The engraver's running at the moment, so the 1.5mm ball nose running. So just while that's doing all those logos, what I showed you there in the SolidCAM 2021 update, that's not everything that's in there. There are lots and lots of feature enhancements in there as well. So just a few of them. I've had to write them down, as that many. Just a few of them. In thread milling, we've now got roughing patterns, so we could do flanking, multi-start. The trochoidal turning operations got some improved logarithm in there as well, so we've got more suitable toolpath at the start of the stock. We've got fixture protection in turning. The HSR toolpath's got smoothing and gap controls in there as well now. Turbo HSM's got some quality improvements, giving you less points, so less code for the machine to handle. And some extra functionality in the 5-axis simultaneous as well, like geodesic machinery. We've also got automatic 3+2 roughing and edge braking and edge trimming. So there's lots and lots in there. Again, that's not all of them, there are lots more. So if you're interested in the update training, for the UK customers, we've got update training event days on. There are 4 dates at the moment. If those get full, we'll put some more on if there's more demand. So contact us for those dates. So one of the other partners today as well is CG Tech, Vericut. So they're one of our partners. We've used them to prove out the code before putting it on the machine. So I'm just going to see here where Andy caught up with Tim, just talking about the event today and what's new in their software as well.
Speaking with Tim from CG Tech. Good afternoon, Tim.
Good afternoon, Andy. How are you?
I'm very well, thank you. Yourself?
Yeah, all good, thank you. Yeah, very well.
Good. What's new in your world, Tim, in CG Tech?
So, I guess the first thing, Andy, is I'm not sure a lot of people know this, but we got bought out by Sandvik towards the back end of last year. So over the last couple of months, we've been sort of integrating with their teams, if you like, and some of our processes have changed, but we will still be CG Tech. You know, that the brand will still stay the same. Vericut is our product. We'll be a business unit under the Sandvik Coromant umbrella, if you like. So it's quite exciting times. You know, there's going to be a lot of opportunity for both CG Tech and Sandvik moving forward. So that's quite exciting for us. So that's
it'll be very exciting.
Yeah, absolutely. We're all looking forward to it, and already, you know, it's started off pretty well.
Good. And anything else that's new and exciting?
Yeah, well, you know, obviously in these times at the moment, Andy, it's very difficult to get out visiting customers. So instead of sort of doing demonstrations for our customers, we've started doing little tips and tricks, which we're putting on social media. So look out for them on YouTube, LinkedIn, Facebook. Literally just 2-minute video clips of product features to help our customers out. You know, that some people might not know about these features. So we've started doing that this year, which has gone down pretty well so far.
Oh, that's good to hear. Obviously using social media these days, as we all have to do, to try and keep in contact with our customers.
Exactly that, yeah. I mean, it'd be great when we can see people face to face, but while we can't, you know, that's the sort of thing that we're doing.
Yeah, that's good. And anything else? I believe there's a new version coming out?
Yeah, there is, Andy. Yeah, so version 9.2 will be with us probably sort of autumn this year. There's going to be a lot of new enhancements in that, all about, you know, better, faster, quicker, easier, those sorts of things. other functionality in there that's quite exciting. Something called GDML, Geometry Description Makeup Language. I had to look at my notes there to get that one out. And that's basically gathering 3D information off models that we bring into the software. So that should open a lot more other opportunities up for us. Force optimization is always something that our developers are looking at and enhancing, so that'll make it easier for our customers to be more productive, basically.
It seems like it's exciting times for yourselves up at CG Tech, especially with your consolidation with Sandvik. I hope everything goes well. Thank you for joining this afternoon, Tim, and we look forward to doing some more of these in the future.
Brilliant. Thanks very much, Andy. Yeah.
Thanks, Tim.
We
See you.
Enjoy these.
It's a pleasure. Bye.
Cheers. Thanks, Andy. Bye.
Thanks, Tim. As always, your support of these events is much appreciated. You can see the machine's finished at the moment, so it's literally just finished the logos there with that engraving. So I'll brush the part down and get in front of the camera shortly. So just while I do that, just wanted to show you one of our recent success stories, our customer success story with a company called Gilbert Gilks and Gordon. And again, this was involving our tooling partner, ISCAR. So I'm just going to show you that little story first, and then we'll come back and have a look at the component.
So I wanted to share with you today one of our latest success stories involving our customer Gilbert Gilks and Gordon. We were first introduced to this customer alongside our technical partner ISCAR, and Gilbert Gilks have been tasked to start producing this component from a solid billet in-house, bringing their manufacturing more controlled and overseeing the complete process rather than buying in this particular product. Now you can see here a lot of this component is going to be done with simultaneous 5-axis, or a lot of the finishing is done with the simultaneous 5-axis. You can see here we're using the barrel cutter as well from ISCAR's multi-master range. You get the reach over the top of the So I wanted to share with you today one of our latest success stories involving our customer Gilbert Gilks and Gordon. We were first introduced to this customer alongside our technical partner ISCAR, and Gilbert Gilks have been tasked to start producing this component from a solid billet in-house, bringing their manufacturing more controlled and overseeing the complete process rather than buying in this particular product. Now you can see here a lot of this component is going to be done with simultaneous 5-axis, or a lot of the finishing is done with the simultaneous 5-axis. You can see here we're using the barrel cutter as well from ISCAR's multi-master range. You get the reach over the top of the component to finish the outside walls of these buckets, as they are known. You can see also that the customer is using CG Tech Vericut to verify the NC code once completed. Before running this on the machine, they want to be 100% sure. With a complex component like this, it makes sense to run this through their virtual machine first. Now, SolidCAM gave the customer full and complete training. We also had a few days on site as well with them, helping them to program this first component, giving them the experience and the knowledge needed to continue producing these components and the variation of components that they have in this line. Now, working with ISCAR, again, we'll work closely with
with the technical team from ISCAR, coming up with the methods for these tools, coming up with the strategies needed, and also helping them with the tooling that they would need to get into certain areas as well. As you can see, the buckets are quite close together on this component, meaning that there's very little access down in the root of it to be able to rough and finish in this area, but particularly from a finishing point of view, very difficult to get down there. However, using SolidCAM's powerful 5-axis strategies and the collision detection and avoidance, we were able to achieve this and get right down into the bottom of those buckets and right over the top into the areas needed for finishing. Now, previously when Gilbert Gilks were purchasing these components from a third party, they were coming in and they were needing some heavy polishing to finish these areas, finish some of these surfaces to get the required surface finish needed for the component when it's working assembly. Now, using SolidCAM, using the ISCAR tools and using their new machine that they've invested in, they're able to minimise this polishing afterwards. It's coming off the machine nearly in a state ready for assembly. There is very minor polishing going off to finish these areas and these tight big areas. You can see here the tool going right down into that bucket, and you can see SolidCAM simulation there mimicking exactly what the machine is going to do, and also then the very cut simulation as well as a secondary check to ensure that the code is going to work as it should do. So working in conjunction with our technical partners is very important to us. We will always work with any partners necessary to achieve the end result for the customer and to achieve the finished product. Gilbert Gilks are now working on their next products in this line, already completed another one on the machine with very little assistance from us, showing the ease of use and the power of the SolidCAM software, and also the training that they had has given them the ability to be able to program these complex components with ease and with very little problems.
Okay, so hopefully you understood. Well, we got the sound working in the end on that one as well.
Again.
Somebody's going to get an earful. But no, hopefully you enjoyed that user story on there. Very, very good customer of ours, and a very interesting story and well put together on there. So hopefully that was good. We're going to move across now onto a slightly different application. We've got and have had for several years now full support for sliding head machines. So we're going to go and delve a little bit into that area now. We've got Darren Taylor from ISCAR who will give us a quick presentation of their support for the miniature tools on here. So that will be first, and then we'll go straight into an overview, if you like, of SolidCAM support for it. We have limited time on these presentations to show you absolutely everything. So please ask questions. If you are interested in this, then please contact us as well. So over to Darren. Thank you.
We're talking today to Darren Taylor from Iscar Tooling. Good afternoon, Darren.
Good afternoon, Andy.
Darren, over the past 12 months, SolidCAM have been promoting our module for sliding heads, and I believe Iscar have a dedicated range of tooling for sliding heads. Could you tell us a bit about that, please?
Yeah, we have a full range of dedicated Swiss tools for sliding head machines, based around quick change tooling. We all know that the major cost is when the spindles are not running. So Iscar have tried dedicated tooling with quick change around, so there's less downtime on the machine. This has been a mainstay probably the last 10 years of that particular Swiss system.
Well, that's good. Have you got anything new for 2021 that we can talk about?
Yeah, we've a new Swiss grip parting system that's just about to be launched. If you keep an eye on Iscar's website, you will see when it's actually live. This is a kind of industry first. We have an indexable parting insert at 0.6 of a millimetre and 0.8 of a millimetre. That's where you get a good cost saving. If you're machining some exotic materials, which we all know are very expensive, smaller the part off insert width, chances are you can make a couple of extra parts per bar. Good cost savings.
Well, that's great. That's good news to the market there, Darren. Well, thanks ever so much for your time, and thank you for joining SolidCAM Live.
Not a problem, Andy. Thank you.
Thank you. Bye-bye.
Hello and welcome. Today I want to give you a quick overview of SolidCAM's support for sliding head or Swiss type machines. This demonstration will be shown on a Star SR38. This machine has all the main characteristics of sliding head machines with the addition of balanced turn capabilities and a fifth axis, which we can demonstrate today. We feel that local support is vital in this complex world, and in the UK we've employed 2 experts in this field to both develop and support this market. This gives us local capabilities to create NC output for any machine and indeed tailor the output for individual preferences here in the UK. What you'll see over the next few minutes is that SolidCAM interface and the method of programming has not changed throughout the product, keeping the ease of use simple yet extremely powerful. Firstly, we'll look at the part setup. At any point in programming we can preview the current machine position. Here we can see and graphically select the pick-off position to use in part transfer. We can then start the machining. Firstly we'll face the component, selecting directly from the solid model and the tools from the library. These tools are previewed in their stations, easily identifying and showing their correct setup. Next we'll rough the main turn profile using balanced turning. This gives double the metal removal rate as 2 tools are used simultaneously. Here again we select the geometry directly from the solid model, and this time we select both the master and slave tools from the tool library. There are options to control the radial steps for each tool within the software, and here you can see the resultant toolpath, simulated both as a solid and our first view at machine simulation. So here we can see the full machine working as it would do. Now we machine these slots around this face. They are 4-axis simultaneous slots at a 5-axis position. So this is done purely by selecting the tool and the faces from the geometry on there. These could also be copied around, so we only have to program one and we can copy that around the axis on there to generate all the separate positions. So here it's being simulated in solid, and again we can put that on the machine and view this so we can be sure that everything's behaving and working as we expect it to, giving us the confidence that this is actually going to happen on the machine as we expect it will. Using SolidCAM's multi-axis drilling operation, the holes in these faces can now be added simply. The hole orientations for the B and the C axis are generated automatically from the hole positions in the model, so all the user needs to do on there is to select the correct tooling and the correct strategy for it, and the holes can be easily machined within there. Again, this can be easily simulated on the machine simulation as shown here, which would include full simulation for pecking and other strategies. Transferring the part from the main spindle to the sub spindle is simple. pre-position a part-off tool. The catch position has already been defined. We did that in a setup earlier. Perform the part-off, retract the sub-spindle, and it's done. Working on the sub-spindle is exactly the same as it was when we were working on the main spindle. Same definition, same dialog boxes. We try to keep it simple. Everything is very graphical, and again we can simulate this the same as we did with everything else on there. You can also see on there it's giving us help, it's giving us spindle directions within the machine simulation. Everything else is worked out exactly the same way, so again we can see everything as we go along to make sure everything's good. Once program is complete, we can now look at synchronizing it. So here we can see the synchronization as it naturally is, with all the work on the main spindle, then the transfer, and all the work on the sub spindle. That can be easily optimized on there to work on the sub spindle at the same time as the main spindle. Here we can see we've got some clashes, some things which can't be worked at the same time. SolidCAM identifies those and displays them to us simply, so that we can put the relevant weight marks in there to make it work as we need it to. Once we've done that, we can generate the G-code. So here's the G-code displayed in our SyncMaster software. This software has been developed to highlight and to show all the weight codes in there to make sure everything's good before it goes down to the machine. That concludes our quick overview of SolidCAM support for sliding head Swiss type machines. If you'd like more information or a more in-depth demonstration on your parts if you like, then please contact us. We'll be more than happy to do this. Many thanks. Okay, so just a very quick and brief overview of our support for sliding head on there. One of the things which we're planning at the moment is to have a full event on sliding heads in May. So again, watch this space. We'll go into a lot more detail of it there. If it is of interest to you, please contact us. We can go through absolutely everything on here. As I said in my initial overview, my welcome on there, all support for these sliding head machines software is being done locally in the UK. So if there's anything you need in the UK on this, please contact us. We can manage that here. So just to conclude on that, we've just gone through pretty much everything on the agenda now. We'll just switch, I think Ben's just switching it across so we can see the finished components in the machine. I'll pass you back to him.
Yeah, so the component's finished now. I've moved the camera so you can see it there. You can see those logos. You can see everything's mirrored as well. So as I showed you in the presentation, just right-click mirror. You mirror it about the plane, and it will do all those toolpaths again on the other side. So respecting the climb milling, changing the direction, etc. All complete. So that's the part complete. I'd like to thank all the partners for being involved, all the support we've been given for this event and previous events and future events coming up as well. It's always great to get together and do these things. So yeah, from me, thanks very much.
Yeah, again, I'll add my thanks to our partners on there. It's a big effort, it's a big commitment for all the partners to support us at these events. We really do appreciate it. Thank you to all of you people for taking the time to actually come and watch it. It's pretty lonely up here doing it to an audience of 1 or 2. When we've got an audience of 300, it's well worth it. So again, thank you very much for that. Stay safe, everybody. Take care.